Hi, everyone. I'm Xiaoming. I'm a senior data scientist at Loblaw Digital. And during my work, I focus on the personalization and recommendation services and the machine learning model deployment infrastructure. So in today's talk, I'd like to share the following topics, including how we are doing data science at Loblaw Digital, how we work mostly happily together with other teams, and the typical workflow, how we test, build, deploy, monitor, and repeat this cycle, and follow with a brief case study of building a data science service, including the tech stacks and general solution architecture. So at Loblaw Digital, we focus on the e-commerce business of our company, including PC Express for grocery pickup and delivery from different banners, Beauty Boutique, PC Optimal, and Joe Fresh. So today, my talk will focus on our work of personalization and recommendation. And through our work, we are trying to have the customers finding relevant products more easily and stop receiving irrelevant messages and have less friction in their shopping experiences. So in a typical personalization recommendation project, our data science team works together with other teams to deliver our product and surface it to the customers. So on the tech side, we have our data science team, software development team, and SRE teams. We work together to deliver our project, to build, integrate, and maintain the service. And we are also leveraging the Google Cloud Platform for our infrastructure, using the managed compute and storage or database services on the cloud platform to build our service. And we productionize our machine learning models at the collections of microservices. And each of these services has a narrow scoped purpose. For example, it could be the recommendation at landing page, or some inspirational content article recommendation, or it could be some relevant items on the product detailed page. And each of the service has its own code base, and we achieve per service control on things like the scaling, permissions, authentication, and security and policies such as timeout, retries, circuit breaker, things like that. And we have a freedom to choose language and stacks for each service. So during our collaborations of building a personalization or recommendation product, our data science team, we work on this pipeline, including ETL of feature engineering and model training and inference, deploy the model, build the REST API service endpoint, and implement model experimentations, for example, A/B testings from the backend. And the software development team, they will build the e-commerce core capacities such as products, cards, search, or identity access management, and build the digital front end and middleware services. During our collaborations, we provide the API. We hammer out the API contract with software development, and their services will be our API consumer, and they could integrate our microservices as well. During this process, of course, it will enforce a good API design. And for the DevOps, SRE or DevOps teams, they will maintain the infrastructure, GCP resources, Kubernetes clusters, network, and security stuff. So for these two teams, we communicate with them for this service level indicator, objective, or agreement. And we will obtain the requirement from the software development team, and also communicate these numbers to the SRE team, so we could monitor this service health status together. And also the SRE team will provide a shared on-call support for our services, so we could make it live 24/7. And on the business side, the product and the experimentation team will make sure our services will perform and deliver value and align with business goal. So for the product team, they will design the user stories and propose business requirements for us, and create roadmaps and propose the KPIs. And for the experimentation team, they will obtain the reporting data from experiments and do statistical analysis, evaluate model performance, and provide suggestions on the product. So the basic workflow of building a data science service has following steps. We write the application code and describe the deployment as the Kubernetes manifests, containerize and deployment to Kubernetes, and keep monitoring the service. So in the writing the application code step, we will include things like model inference or backend database query and additional business logic. And if we are doing model testing, we will include the experimentation logic. For example, the traffic routing algorithm for A/B testing or multi-bandit test. And we will also include the middleware code for exporting the model as web services. And in the next step, we will describe the deployment as a Kubernetes manifest. It will include the deployment specs and other required resources, for example, for the ingress, egress, credentials, and security policies. So next, we will containerize the application and using GitHub CI pipeline to test, build, and deploy to the cluster. So we can deploy things gradually. We always canary things and leverage tooling and automation, for example, the GitHub CI and the tools like Helm. And we are able to deploy new models in the future and seamlessly A/B test them. So after the application is deployed, we are able to achieve central observability through rich operational logging, monitoring, and tracing. So basically, we are looking at things like service health status metrics, things like RPS, latency, errors, and we build alerting rules on these service health metrics. We can also monitor the model behavior, for example, these feedback signals and customized metrics. So things like how many times a particular recommendation items is requested. And we can analyze logs. We are using the BigQuery as log sinks, so we could perform some SQL queries on the container logs and get some insights. So we can further monitor model performance and build feedback loops. As a data-driven team, our principle is to measure everything through container logs, emitted metrics, and some user interactions during each sessions. So we can look at things like click-through, add to cart, and things like that. And we can also look at the transaction logs to study the purchase patterns and other business metrics like the population of subscriptions. And we can adjust the model assignment in the experiments by linking the model performance to the metrics. Then we could either manually adjust the traffic routing or do it automatically. So more specifically, we have different experimentation strategies to test the models behind our service endpoint. We can implement A/B testing to randomize the traffic splitting to route to different models. So we are able to collect the statistics for model performance evaluation. And with the feedback loop, we can also achieve dynamic routing through multi-bandit test. So here we have a routing component that decides how automatically to adjust the model assignment by taking account the feedback signal. So I'd like to briefly share a case study of building a recommendation service. For example, we can provide personalized product recommendations on our landing page or push relevant inspirational contents in our PCO app. So this is a really high-level design of an inspirational content recommendations in your PCO app. So we generate this user and product embeddings through transaction history. So we can build the user's affinity collection. And conditioned on that, we use this content metadata to rank what could be the relevant contents to the customer and provide the recommendation. So when user visits the digital front end, the mid-tier will request the personalized recommendation from our engine and retrieve the contents from the contentful CDN based on the UID we provided, and assemble the web page and send to the front end to render the final appearance. And this is a data flow diagram of generating the recommendations. So we decouple the training and serving pipeline to make it more robust and able to make changes independently. The training pipeline is orchestrated by Airflow, and we ingest the data from various sources. For example, it could be some analytical data, digital assets, or some external data sources. And we run feature engineering and training in the Spark job on the managed Hadoop cluster and write different recommendations in Bigtable, which is a NoSQL white column database. So we can experiment seamlessly with different versions of model behind the service endpoint. So this is one piece of our stories for building data science services. In addition to recommendation, our team also service different businesses, including operations and fulfillment, customer growth, and marketing intelligence with various collaboration patterns. So hope our story could be helpful to you, and thank you for your time, and feel free to let me know about your questions. Thanks. Yeah, sure. So feel free to drop your questions in the Q&A sessions, so I will try my best to answer them. Oh, actually, I do get some questions. Okay, so the first question is, what are some lessons you learned through this process? So actually, there are a lot of lessons we learn from this process. So because every time we build a data science solutions, it involves collaboration through different teams, and it is important from the design phase. We need to bring everyone to as early as possible. For example, when we collab from the product team, we need to make sure how the requirement looks like, so we could and during our design process, we need to make sure our overall architecture is extensible. And also with this with software development team, we need to make sure that our service is compliant with their, for example, security requirements or other performance requirements as well. And in the end, it is also important to run different tests, for example, UAT and SIT with different teams, and to test everything is correct and the service is performant. And so hope this could sort of answer your question. And next one is, how has your team dealt with split data sources in different silos during the ingestion? So actually, yeah, like from our, let me show this. So for example, in a typical recommendation service, we could have very different data sources. So you can see that we'll try to reduce the silos. We'll try to make sure everything is all the data we needed is gathered on our GCP platform, especially on BigQuery, and or in the other storage buckets or so just make sure we in our data pipeline we are able to access them either during on streaming or batching jobs. So try to make sure. So it is also dependent on our other ETL pipelines. So as long as we can make sure all the data we needed is constantly updated and gathered on our analytics data warehouse or some other resources, we'll be able to build a robust data pipeline to ingest them. And you mentioned you have to, okay, another question is you had to deal with a lot of data movement. So this is really a big problem with AI projects. So what did you do? So could you specify what is the data movement you're talking about? Like, for example, when we are building this recommendation services, the data is always need to be updated. So it is dependent on other ETL pipelines as well. Make sure this the data source is robust and backfilled regularly. Yeah. So for the so for the ETL pipeline, so for when we have different resources, for example, for the transaction logs, it depends on our on the streaming ETL pipeline to ingest and to ingest the transaction logs. So internally, we have our Kafka cluster to deal with this problem. Make sure our T logs is almost real time, or at least 20 minutes in latency. And also in other projects, for example, if we are looking at some metadata, so we could also have the ETL pipeline that is triggered when there's new data added. For example, this the pipeline could be triggered by we are adding new records in the database. So it is triggered, and we could update our data source as well. So if there are any more questions, hopefully this could answer your question. Yeah, sure. So if you have any further questions, feel free to ask me on this conference platform. I believe it has the ability to send messages.